Hi, today is important milestone, 15 days. So let's start with right, and there are n vertical lines drawn such that the two endpoints, of I line are e and 0 and I and height. Find two lines that together with x axis, so we have y-axis and x-axis from the container such that the container contains the most water, returns the maximum amount of water a container can store. That you may not slant the container. All right, so we have an array of heights, and our task is to return the maximum integer. It will be maximum height. Maximum, it will be area, right, of water. All right, so let's draw some test cases. So let's say we have 1, 2, 4, 2, 3, 4, and our result would be the following. So we have one container. So let's draw what containers actually we can have here. So if we will put 2 pointers at the beginning and at the end, so we see that the maximum container here is 1, right? So an area, so first area, let's have like this. So first area would be 1 because we take a minimum value between 1 and 4, and we multiply by j minus I, where j is here and I is here. So at the beginning we have an array of 6 elements. So here would be 5 and here 0. So here is 5 because we actually can check 1, 1, 2, 3, 4, and 5, right? So here the result would be 5 multiplied by 5. It would be 25. Then second one, what we can do, we can move our least container. So we move it here. So now we have 2 and 4. And we again calculate, so it will be minimum 2 and 4. And we multiply j minus I. And it would be 2 multiplied by 4. And here, here is 1 multiplied by 5, so it would be 5. And here it would be 8. Then we again move. And now we move and it's equal. So we have 2 equal elements. And now here we have 3. So it would be 4 multiplied by 3, 12. Then we move once again. So I believe that here is, if we move 2, but we also can move 4. So here I think it's interesting, like which one should we move if they are equal. If they are equal, so we can, for example, move here. Let's say like this. So if we move here, so we have 4 and 3, we take minimum 3, and then we have 2, so it would be 6. Or we can move 5, so here we can move like 2 and 4. We can do like this, and then we have 2 and 2, it would be 4. If we move for here 3, right, we can continue moving, and here it would be 2. So this one would be 6 with minimum between 4 and 2, and multiply by j minus I, and it would be equal to 2 multiplied by 1 would be 2. And here, if we will move, it would be 3. So it's 3 and 4. And the minimum 3. So it would be 3. Yeah, so it would be 3. So we see here actually these use cases. So I believe that the main question here, it would be what should we do if we have the equal scenario. So for example, here we calculate, then we go here, and logically is correct to move an element if the next one is bigger. If they are equal, again, I think we can just move random one for now. So let's try to implement this logic. So let's have 2 pointers, as we said. And while j minus I is greater than 0, we do this operation. So let's have our result, and let's return it. And what we do, we take result, and it would be mass maximum between result and mass minimum between height I and height j, right? And then we should multiply this minimum by j minus I. And here it would be actually result. Then what we should do, we should check if height is equal to height j and and high I is greater plus 1 is greater than height j minus 1, then we move our left pointer. So it's actually our first logic, and then the second logic, if we should move left one, so if it's less than the current one, so if height I is less than height j. And here we should do I++, otherwise we should do j minus minus. And and we should do these operations. So let's just run and submit. And we see that we run correctly. Let's check what we have here. So we even can do it like this without this complexity. So the same. What's the difference? Yeah, so actually the same, like 2 pointers here. So quite understandable task. So let's go to the next one. Vote to save people. So we are given an array of people, and the people I is the weight of each person and an infinite number of votes, where each vote can carry the maximum weight of this limit. Each vote carries at most 2 people at the same time, provided the sum of the weight of these people is at most this limit. Okay, so we should return the minimum number of votes to carry every given person. And we are given this number of people. Okay. So the idea here is the following. So let's just try to understand the problem. So we have an array of people, weights, and we should return, and also L, it will be a vote limit for 2 people. And we should return the minimum number of votes. Let's try to write some test cases. So for example, if we have people like 1, 3, 4, 5, 8, and limit, for example, we have 9 for 2 people. Then what we can do actually, we can we can try to get 2 people. So if it's possible, to place 2 people here, because we should take like maximum from here. So if it's possible to put these 2 people, it means that all other people, not always, but let's think about it. So here the result would be like we can put 8 and 1, then we can put like 3 and 5 and just 4. So here we need actually 3 bolts. We need 3 bolts. But what if we have here 9 and we cannot put, so it would be like separate person. Then we can put this 2 and this 2. So it will be like still 3 bolts. But what if here we have 8 also can be 3 bolts? Also can be 3 bolts. So what we can do, we can just go through 2 pointers and we move our left. So if we, for example, put this one, we're left with, and here we try, if we put this 2, we move this 2 pointers, and again we try to understand if we actually can put 2 persons here. So we have 2 pointers from both sides and limitation. So if limit minus right and limit minus L is greater or equal to 0, it means that we can put these 2 person. If it less than 0, then we can put only this person here, and we move this pointer here. But the problem here is that we see that this array is unsorted. So probably the first idea would be here, it's to sort this array. and then have these 2 pointers. But also I believe that we can do it with n squared when we have 2 loops over our people. We also can do this. We also can do this, but if we have not sorted, it would be, I believe, not optimal. So let's try to implement it. So we have arrays sort. We sort in our people. Then we have 2 pointers here. So it would be people lengths. Then we have a while loop while j minus I is greater than 1, then 0. Yeah, and here we calculate if limit minus people j minus people I is greater or equal to 0. Here it would be our result. We return this result at the end. And we increase our result by 1, but also we move our 2 pointers by 1 position. Else we move only j, because we want to put the maximum person to our boat. Yeah, and in this case we increment also we always should actually increment our results here. And I believe in the end we also should increment our results. So let's take this example and let's debug this code. So we have result that is equal to 0. We have limit of 9, and we have 2 pointers here and here, and then we check. So 9 minus 9 and minus 1 is not greater than 0, so we just move this pointer and we increase our ball to 1. Yes. Then we see it's equal to 0, so we actually move our 2 pointers and increase to 1. And here we have again, it's greater than, because 9 minus 7, it would be 2. So it's greater, so we just increase to 3, and and move our 2 pointers, and so they becomes -1, and we just return this result. Yep. So I think that's work this way. What if we have another? For example, if we have all 9s, so what we have? So we have like this one, right? And we put 3 boats, and then we have again 2 person, but then they still here. So if I is equal to j, then 1, otherwise 0. So we should do like result plus 1 or 0 in this case, in this edge case. Okay, 1 and 2, limit 3, and output 0. So let's check. So we have people, we have 2 pointers, j minus I should be 1, then we can do like this. So limit here is 3, minus 3 should be 0. So we move y by 1, and here it would be j 0. Right? Here would be minus 1. And it's not equal. Yeah, and we should like increase our result by 1. Okay. Okay, and we're done. So we beat 82%, but we see that it's quite not a lot. Okay, we have sort, sort, sort. So everywhere is sort. Let's check our previous. So you can sort. Result of 1. What if we remove this one? Yeah, so we see the same. Yeah, so we actually need this. We need this. Yeah. Okay, so I think we're done with this task, so let's mark it as done. Right, so for today, I believe that's all, because the next one would be Draper in Rainy Water. It should be quite complex, so let's see tomorrow.